Temperature parameter in large language models is used to control the randomness of its outputs. But in order to show that it's not magic and it's just pure math, let's consider this example. Let's say I have a sentence I like to and I'm trying to predict the next word using a transform architecture. And these are the final output logics in my transform architecture: -1 for study, 0 for sleep, and 2 for play. Now, normally, before even picking a word, what I would do is convert into a probability distribution and then pick a word using that probability distribution. For that, we use the standard softmax implementation of e to power z by the summation of e to power z. When we apply this formula on these predicted logics, I get this as my output: 0.04 for study, 0.11 for sleep, and 0.84 for play. But now this is just a standard implementation. Let's introduce the temperature parameter and let's see how that affects the final probabilities. So in order to introduce the temperature parameter, all I do is divide each of these values by the T constant, right? And you would see how by increasing my temperature, I would get more random probability outputs, more uniform distribution, and how by decreasing my temperature, I would get a more discrete output, which favors the most likely class. For the first case, let's look at what happens when we have a high temperature of T is equal to 10. We should get more random outputs. If you look at the formula, the value of T is in the denominator. So the T acts like a suppressor for the individual logic values. To understand this, let's continue the example. First, we take the Z by T values here, and we're getting -0.1, 0, and 0.2. With these values, if I cancel the probability, this is the probability distribution again: 0.29, 0.32, and 0.39. If you compare this probability distribution with the original probability distribution, this probability distribution is more uniform, right, than the original probability distribution. Now let's consider the opposite case where T is equal to 0.01. When we have 0.01, we will be getting more discrete outputs, and it's easy to see. Now, instead of suppressing the individual logics, T is amplifying the individual logics when it's less than 1. So we have -100, 0, and 200. And when we calculate the probabilities using these values, I'm getting my probabilities as 0, 0, 1. So obviously, one class, which was already the more favored class, became very discrete. So this is how temperature affects the working of large language.